Hello, Kaylee. How you doing? All right. So I use another problem to explain the problem that you sent me by email. So we're going to go through the process of transforming system A to system B, and then from system B to system C. Okay. So first we have to understand that we are kind of using the elimination method in order to transform from one system to another. Okay, so elimination method goes as follow. Basically, you're adding, right? So in order to solve for a system of equation using the elimination method, you have to add the two equations vertically, right? So you add the two equations vertically in order to cancel out one of the variable, the x term or the y term. But unfortunately here, if I'm adding these two, I get negative 6x, and then here I get 11y, right? That's not what we want. We want one of them to be canceled out. So here, nothing canceled out. So what we have to do is to find an equivalent equation of one of those two. So let's say I want to cancel out. So this is, I want to cancel the x terms. So I'm deciding to cancel out the x terms. Okay? So in order for me to do that, right, to add them vertically and then to cancel out the x term, well, the value that is in front of the x must be the opposite of negative 7, right? Because 7x minus 7x is 0x, which means that it will be canceled out. So therefore, I can multiply the first equation by 7, right? And by multiplying this whole equation by 7, that's going to make it equivalent. Okay? Equivalent means the same. So that means that if I were to graph x plus 5y equal to negative 5, or 7x plus 35y equal to negative 35, then I will get exactly the same linear equation or linear graph. That's what it means. Okay? So let's multiply 7 by x, let's multiply 7 by 5y, and let's multiply 7 by negative 5. And we get 7x plus 35y equal to negative 35. Okay? And then we rewrite the bottom one, which is negative 7x plus 6y equal to 35. Beautiful. Now we have 7x and 7x and negative 7x and negative 7x. When you add them vertically, you get 0. You can put 0x or 0. It's canceled out. It's done. Now, that's where we kind of deviate from the elimination method, because now we're transforming system A to system B. How did we do that? Well, we did it by canceling out the first term, right? By adding vertically, but we're keeping whatever is remaining from the transformation, right? From multiplying 7 by the first equation, right? And we are left with 35y equal to negative 35, and we've transformed system A to system B. Notice that system A, B, and C, the second equation are the same, right? The second equations are the same. So we're only transforming, the first equation. So that's that for system A to system B, right? Want to cancel out one of the variable. We have to find a multiple to do that in order to add vertically and cancel out one of the variable. And then whatever is remaining here, then this is what we have for system B. Now, system B to system C, the second equation is the same. But how do we get from 35y equal to negative 35 equal to y equal to negative 1. That's quite simple because now this is just a simple equation. Sorry, that's right. Simple equation, 35y equal to negative 35. All you have to do is divide by 35. Okay? And that's y is equal to negative 1. And that's what I have for my transformed first equation. So I have y equal to negative 1 equal to y equal to negative 1, and then the second equation is the same. And that's it. That's basically it. That's how you go through the transformation. Okay, so this is kind of unusual to solve for a system of linear equation, right? In your textbook, it's probably different, but that kind of enhance maybe your understanding. Okay, so that's it. I hope you understand the process. You can apply that to your first, to the problem that you sent me. All right, so let me know if it works out. All right.